Alright, let's see if I can help you solve these problems that are similar to your take-home. Alright. Here we have an equation. On the left-hand side, we have two terms. The first term is, let's take this actually and copy and paste it to another page. Alright, on the first term here, we have two factors. We have a negative 2 times 19. That 19 has an exponent of k minus 9. We're adding to that the value of 2, and we're getting 35.1. On the left-hand side, these are referred to as terms. Terms are separated by addition or subtraction. So our goal, our first goal, is to get the 19 raised to the k minus 9 by itself. So in order to get that by itself, we must first get this first term by itself. So we need to get rid of the second term. The inverse operation, the thing that undoes addition, is subtraction. So we are going to subtract 2. We also subtract 2 from the right-hand side by our properties of equality. We generally refer to that as balancing the equation. Alright, so we've got negative 2 times 19 to the k minus 9. Sometimes I will accidentally say k minus n for some reason rather than 9. So if I accidentally say that, I apologize. Alright, now on the left-hand side I have two factors. And again, our first goal is to get this 19 to the k minus 9 by itself. If I divide the left-hand side, the inverse operation of multiplication is division. So the inverse of addition was subtraction. The inverse of multiplication is division. Let's divide each side by this negative 2. A negative 2 divided by a negative 2 is 1. So I have this 19 raised to the k minus 9 is equal to this 35.1. It's being divided by a negative 2. I'm going to put the negative out in front. Now, right here, I can save myself a lot of time and effort to recognize that this equation does not have any solution. How can I recognize that right now? Well, an exponent is never going to make your answer a negative. An exponent is simply going to decrease the value. Let's think of terms not of variables right now. Let's just create a scratch work of a little example. Suppose we had a base of 3. And that base of 3, let's give it some exponents and calculate the value. So suppose we had 3 raised to the 4th power. Well, that means that we have 3 being multiplied by itself. This 3 to the 4th, this exponentiation is just repeated multiplication. 3 times 3 times 3 times 3, and I would get 81. And if we had 3 raised to the 0 power, by definition, that's equal to 1. Now, suppose I had a negative exponent, like 3 raised to the negative 1. Well, 3 raised to the negative 1, I can make that a fraction by just dividing by 1. I haven't changed its value. When you have a negative exponent, the base changes location within the fraction, and the exponent changes sign. So this is the same as 1/3. If I have 3 raised to the negative 2nd power, that's 1 over 3 squared, which is 9. So notice that these are positive numbers. All of my answers up here were all positive. I didn't see any value of 0, and I don't see any negative values. And that's going to be the same. If I keep doing this forever, I'm never going to come up with 3 raised to some power that equals 0, or that 3 raised to some power is a negative number. 3 raised to some power is never going to be 0, and 3 raised to some power, no matter what that value of n is within the set of real numbers, it's never going to be, less than 0. Since it's not equal to 0, it's always going to be positive. It's never going to be less than 0. So right here, 19, if someone is making the claim that that's equal to this negative value, this fraction that's negative, that's impossible. So we can immediately say for number 1 that this had no solution. And remember, the solution to this equation is the same solution to our original equation. We just wrote it in a different form. Using properties of equality and balancing the equation on each side, this solution set is the same as the solution set to the original equation, which there was no solution. Alright, so let's go back and take a look at number 2. Your problem number 1 on your take home might have a solution. I'm not sure. A lot of these are going to be similar, but there's going to be a lot of them that do not have a solution. So let's take a look now at number 2. We have the same setup. We've got negative 5 being multiplied 5 raised to the 6x power minus 6 is equal to negative 53. We have two terms on the left-hand side, a single term on the right-hand side. The variable of interest, this x, is here in the first term. For right now, our immediate goal is to get that factor by itself. Alright, so just as before, we look at these two terms and we want to keep this term. The inverse operation of subtraction is addition. We're going to add 6 to both sides to undo that operation. To balance the equation, we have to do it on both sides. On the left-hand side, we've got negative 5 times 5 to the 6x is equal to, and negative 53 plus 6, negative 47. Alright, so on the left hand side I have simplified it a little bit. Instead of two terms, it's a single term. With this single term has two factors. I want to get the factor that has my variable by itself, so I want to undo this multiplication. The inverse of multiplication is division. This is negative 5. We divide both sides by a negative 5. Negative 5 divided by negative 5 is 1. And this time I'm going to leave this as a fraction, but the negative divided by negative is definitely a positive value. Alright, so I've accomplished my first goal. I've got the factor that had my variable completely by itself. Well, now this exponent, I don't have an inverse operation at first that I can get that x by itself, not until we studied logarithms. The inverse of an exponentiation is a logarithm, and we have properties of logarithms that we can use to help us solve this equation. So remember our properties of logarithms. We actually had 4 of them. Alright, so let's take a look at each of these and see if we can make a decision of which one, if any, are going to help us with this problem. We know that if we have the log of some number that's a composite number, a number like 10, that you can break it down to 2 times 5, that the log of 10 is equal to the log of 2 plus the log of 5, because 2 times 5 is 10. So as long if this is a composite number, even if it's a prime number like 3, we could have 3 times 1, and you have the log of 3 plus the log of 1. Doubtful that you would use that. The log of 1 is 0, but the property holds true for all values. They call this the product rule because product is just another word for multiplication. Here we have the quotient rule. Quotient is just another word for division. If you have the log, in this case my examples here are a common log, but it applies to any base, not just base 10. If you have the log of a fraction, you can break this up into two logarithms by taking the log of the numerator minus the log of the denominator. So if you had some number like 24, you could rewrite 24 as 48 divided by 2 and log of 48 minus the log of 2. All right. What about this one, the power rule? That power is just another way to say that you have an exponent. If we have 2 squared, sometimes you'll hear people say 2 to the second power. All right, so what this power rule is allowing us to do is if you have an exponent, that you can take that exponent and move it to in front of the logarithm. So it changes from this b raised to the n power to n times the log of b. So we're changing this exponentiation to multiplication. And then here, this property is referred to as the change of base formula. It's especially helpful when you're trying to use your calculator. You only have 2 buttons on your calculators with logarithms, the common log button and the natural log button. Well, you may be interested in the natural log of, the log base 5, log of 2 base 5, so you can get an approximation for that if you have the log of 2 divided by the log of 5, if it was log base 5 of 2. All right. Now, of these 4, it's this power rule that's going to help us to solve our problem. All right. Here we have an exponent, and we need to get that x by itself. So if we take the log of each side and the log of any base, I'm just going to make it base 10, a common logarithm, because that's what we have on our calculator. If I take the log of the left-hand side, I must take the log of the right-hand side. Now, by the power rule, this exponent, this 6x, 6 times x, comes out in front of the logarithm as multiplication. Now, I can treat this like we did before. And I can say, well, I need to get that 6x by itself. The inverse of multiplication is division. To cancel this log of 5, I'll divide by the log of 5. And to balance the equation, I divide by the log of 5. Log 5 divided by log 5 is 1. We have 6 times x is equal to. Now be careful here. This is not log times this 47 over 5. We cannot treat this as multiplication and try to somehow cancel these 5s and these fractions or multiply them together. We have to treat it separately. This is the log of this is a function. This is not multiplication. All right, so we're almost done. To get the x by itself, the inverse of multiplication is division. So we divide the left-hand side by 6, and 6 divided by 6 is 1. If we take this fraction and we divide it by 6, and we're done. We go to the calculator. When you're keying this in the calculator, when you key in the numerator, I would put the entire thing inside parentheses for the numerator. And when I punch the log button, it opens with a parenthesis. I key in my fraction, 47 over 5, and I have to tell it, I have to close it with that parenthesis to say, take the log of this fraction. Then I want my division, so then I have to divide by the log of 5. And again, I need to close this parenthesis? Well, remember I started the whole thing. The very first thing I keyed in my fraction was this parenthesis. I need to close it. Now I'm having the calculator perform these operations that are in the numerator there. When I go and I divide by 6, because I've closed that, it has this numerator divided by the denominator. So let's see what my calculator gives me as a decimal approximation, and we'll have the value of x in our solution set. Alright, I've got log Alright, if I carry, I have my calculator set to 4 decimal numbers, and I get that x is equal to 0.1134. Alright, let's pause. I had to pause the recording for a minute. In speaking out loud and saying the things that I didn't close my parentheses and stuff correctly on my own calculator, and I got a little bit nervous that I wasn't getting one of our 4 answers, but I get 0.2320. So I had to follow my own advice. If you don't have the correct parentheses, if you don't tell the calculator exactly how you want this calculated, you're not going to get the correct answer. Alright, so that's what I have for number 2. Let's move on. Let's take a look now at number 3. Now hopefully you're beginning to recognize that there's some repetitiveness in these type of problems, because we again have a single term on here that's -9 times 18 to the n minus 2 plus another term is equaling on the right hand side a term -5. We want to get eventually the n by itself, but our first goal is to get this factor 18 raised to the n minus 2 by itself. So we come in, and we want this term, we want to undo this adding one, the inverse of addition and subtraction. If we subtract 1 from both sides, what do we get? Well, we get this term that has 2 factors, and one of these factors has our variable of interest. Alright, with these 2 factors, we want to keep this one. We want to get rid of the -9. The inverse of multiplication is division. And -9 divided by -9. We have this 18 to the n minus 2. Negative divided by negative is positive. 6 divided by 9, well, it's easy to see that they're both divisible by 3, that 6 divided by 3 is 2, and 9 divided by 3 is 3. You can reduce your fractions. You don't have to. You can keep it as 6 over 9 and just let the calculator do the work at the end. Alright. Again, now we've gone as far as we can with just our properties of equality, and looking at inverses. We need to think, well, what's the inverse of having an exponent? That's the logarithms. That's one of the reasons, the primary reasons we study this in this skill set, is to solve equations that have variables as an exponent. So by the power rule, if we take the log of the left hand side, to balance the equation we have to take the log of the right hand side. Let's go ahead and put that in parentheses to emphasize we're taking the log of 2/3, not the log of 2 divided by 3. Alright, so by our power rule, our exponent comes down out in front of the logarithm as multiplication. So that is the reason that we studied logarithms here. The n minus 2, and I need parentheses around that because it's the entire exponent that gets pulled down, and it's now multiplication. This n minus 2 is one factor times the log of 18 is equal to the log of this fraction. So on the left hand side we have two factors. N minus 2 is a factor and log of 18 is a factor. We want to get the n minus 2 by itself. That factor contains a variable. Alright, so the inverse of multiplication is division. If we divide both sides by the log of 18, how will that simplify? How will this help us? Log of 18 divided by log of 18 is 1. 1 times anything, you get that thing back. 1 is the multiplicative identity. So n minus 2 times 1 is just the n minus 2. This does not mean log times 2/3. So we cannot simplify this any further on the right hand side. Alright, these two terms, we want n by itself. The inverse of subtraction is addition. And if we add 2 to each side, we'll have our final answer that we want to punch in the calculator and get an approximation for. Adding 2 on the left hand side, these cancel each other out. Negative 2 plus 2 is 0. 0 is the additive identity. Anytime you add 0, you get the identical thing back. So 1 is the multiplicative identity and 0 is the additive identity. And when you hear identity, in this case, it means you get the identical thing back. Alright, so let's go to our calculator. Let's be cautious with parentheses. I've got log of 2/3, close my parenthesis, log of 18, close my parenthesis, plus 2. Alright, 1.8597, 0.8597. Let's look and see. 8597, hey, that was one of our choices, choice A. Alright. Another problem, very similar to the previous three. We've got negative 7.8 times 13 raised to the negative r power minus 2 is equal to negative 84. On the left hand side I see two terms. My variable of interest is r. It's in this first term. Within that first term there are two factors. The 13 to the negative r is the factor that eventually I need to get by itself. Alright, so first I need to get this term by itself by canceling the negative 2. We'll add the inverse operation of subtraction is addition, and to balance the equation we'll add 2 to each side. Alright, on the left hand side we have two factors. We want to get the factor that's 13 to the negative r by itself. This factor of negative 7.8, we would like to just cancel it. So the inverse of multiplication is division. If we divide each side by negative 7.8, what do we have? On the left hand side we have this 13 raised to the negative r that's by itself. Negative divided by negative is positive. And for now, I'm just going to leave this as 82 over 7.8. Okay, the inverse of an exponentiation is logarithms. We're going to take the log of each side. If we take the log, and we can do that, take the log of each side, and the log can be of any base. We're choosing a common logarithm because we're getting a decimal approximation from our calculator, and our calculator only has two log buttons, the natural log and the common log. Alright. Logarithms have a property. It's called the power rule, and that power rule allows us to take this exponent of negative r and change this to multiplication. Moving this negative r out in front changes this to multiplication. On the right hand side we still have the log of this fraction. Alright, so on the left hand side we have two factors. We want to get the r by itself, so let's divide both sides. We want to cancel that negative sign as well, so we'll divide by this time the opposite of the log of 13. Alright, on the left hand side the negative divided by negative is positive 1, and log of 13 divided by log of 13 is just 1. So we're done. If we key this in the calculator, what do we get? We have the log of this fraction. Don't forget to close the parenthesis after the dividing by the 7.8, divided by, and in parentheses put, since we're taking the opposite, put parentheses around this entire denominator. If you do that, I get a negative at negative 0.0195. Alright. Let me pause this again. Alright, I'm back. Again, I made a silly mistake, and I don't know how to help people to eliminate the silly mistake, and you may have recognized it as I was this video. Do you see the 82? 82. Because this was 7.8, somehow mysteriously I changed 82 to 8.2. I have no explanation of why I did that. That's not a property of equality. You may have noticed it as I was writing it down and we're screaming at the screen. Alright, so now let's try this again and see if I'm getting the correct value. I apologize. That's the second time I've made these one calculator error, and here just copying my own handwriting down. Alright, try this again. And that's the nice thing about that this was multiple choice, is that you can catch your mistakes like that. Alright, so negative 0.9172. There we go. Choice D. Sorry about that. Alright, now let's take a look here at number 5. We have two terms. One of these terms contains the variable of interest A. This term is being added to another term. That's equal to, on the right hand side, this term of negative 83. So our first goal is to get this factor by itself. We see that our variable is an exponent, that when we get that factor by itself, we'll take the log of each side, and then from there the two-step equation, add 3 and divide by 3, and we'll be done. So let's subtract 10 from each side. And let's divide each side by negative 2. Negative 2 divided by negative 2 is 1. We've accomplished our first goal, which was to get that factor that contained our variable by itself. the inverse of exponentiation is logarithms. We take the log of each side. That will undo our exponent. This exponent comes down as multiplication. And because I need to multiply log of 11 times that entire thing, not just my favorite term, I need parentheses around that. Alright. Let's copy this onto another page. We have multiplication. The inverse of multiplication is division. Log 11 divided by log of 11 is 1. Alright, so now in 2 steps we'll have our answer. Let's add 3 to each side. And we'll divide each side. This is multiplication. The inverse of multiplication is division. To cancel that 3, we'll divide both sides by 3. So we've got this entire complicated expression that's being divided by 3. So we're ready to go to our calculator. We have to be careful with how we enter it in. Put parentheses around your entire numerator. Put parentheses around your, well, in this case, we're divided by 3. I guess I don't need the parentheses in the denominator. Alright, I get 1.5337. Now, I've been checking my answers by looking to see if it's among our choices. If it weren't a multiple choice, I could take this expression, the 1.5337, and plug it into the original equation to see if the left-hand side does equal the right-hand side. Alright, so this time I must have keyed things incorrectly and got it there that I'm getting C as a choice here. Alright, let's take a look at number 6. And it's like the others. We've got 8 times 13 to the 5.6 n plus 2 minus 9 is equal to 3. We have our first goal is to get this factor that has our variable of interest is n. We need to get that by itself. So first we need to get the factor that contains that variable by itself. Let's add the inverse operation of subtraction is addition. So we'll add 9 to both sides. The inverse of multiplication is division. We've got 8 times this. We'll divide both sides by 8. Eight divided by 8 is 1. So these 8's just simply cancel. Twelve and 8 are both divisible by 4. So they have a common factor of 4. 12 can be written as 4 times 3. 8 can be written as 4 times 2. Since this is a single term here and a single term there, we can cancel out these common factors. Alright, the inverse of an exponent is a logarithm. By the power rule, we can take our exponent and move it out in front to get multiplication. So we move the entire exponent. I need parentheses around that because it's each term inside that is getting multiplied by the log of 13. Alright, so since this is multiplication, I'm trying to get the n by itself. I'm just going to divide each side by the log of 13. Log of 13 divided by log of 13 is 1. Alright, so two steps, subtract 2 and divide by 5.6, and we'll have our expression for n that we can then go to the calculator. So the inverse of addition is subtraction. And the inverse of multiplication is division. So if we divide both sides, if we divide this side by 5.6, we've got to divide this side by 5.6. And we are ready now to go to the calculator. So if I haven't made, again, any silly sign errors or copied something down incorrectly from one line to the other, I am getting negative 0.3289. Choice B. All right. So let's solve this equation. It has two terms. We want to get the term that contains our variable by itself. We'll subtract 2 from each side. We'll divide each side by a negative 1. Because, really what I'm doing here, maybe people need to see this, the opposite of this. I can treat that negative sign as a negative 1 times that, right? So when I say that we were wanting to get this base by itself, maybe I should correct that and say that I wanted to get that, not include that negative sign. Here, when we divide by negative divided by negative is positive, and it may have been our first problem. We have seen this before. We have seen that if you have an exponent, a negative exponent is not going to make your answer negative. In fact, there is no exponent that will make this answer negative. So we can conclude right now that we have no solution. If we didn't recognize that, and we continued to solve for this by taking the log of each side, eventually what you're going to be taking, when you keyed in your calculator, the log of a negative number. And your calculator is going to recognize that you can't take the log of 0, you can't take the log of a negative number, and it's going to give you like a domain error. And sometimes that'll cause students to slow down and think, and you do have to slow down and think, hey, did I key this incorrect? Why is this saying a domain error? Why am I getting the log of 0, the log of a negative number? Is that correct? Is that what I wanted, or was that some type of a silly error? And in this case, the negative sign is correct, and you can't take the log of a negative number, so it's going to tell you a domain error. Some calculators do recognize that you can use complex numbers, and that's beyond the scope of this course, but some of the calculators will give you an answer, and it has some I in it, and a better answer than no solution may be to say no real solution. So here, this no solution, if they would have said no real solution. All right. Let's take a look at number 8. We have two terms. We want to get the factor that contains our variable by itself. So to get this first term by itself, we'll add 5 to each side. Those terms will cancel, and we have 6 times 3 to the negative 4x minus 5. Okay, so to undo this multiplication, the inverse operation of multiplication is division. If we're multiplying by 6, we'll divide by 6. 6 divided by 6 is 1. We have 3 raised to its exponent. Both of these are even numbers. So therefore we can divide each by 2. Half of 38 is 19. Half of 6 is 3. You don't have to do that. You can let the calculator do that work if you want, but I can't resist simplifying my fractions. Boy, it's not going to let me pick that whole thing. All right. Take the logarithm of each side, and we can pull this variable down as multiplication by using the property that's called the power rule. Alright, so this exponent comes down out in front as multiplication. The inverse of multiplication is division. we had an announcement. It's about 6:30 in the morning, and they are looking for Mr. Ferris. All right. Let's get this variable by itself. Two-step equation. We'll add 5 and then divide by -4. If we add 5 to each side, and if we divide by -4, let's go to the calculator. Being cautious with our parentheses. If I have not made any silly mistakes, I have -1.6700. And you can put the 0, 0 there. We have choice B as our answer. All right, I'm going to stop this video and do the logs. The rest of the equations are log equations. The ones we were just doing were exponential equations. So we have 8 of those.